All right, everybody, hello and welcome back. Today what we're going to do is we are going to work on solving nonlinear systems of equations. Now, in order to kind of get the juices flowing here a little bit, what we are going to do is we're going to start with a linear system. So we have the system y equals 2x minus 3 and y equals negative 1/3 x plus 4. What I'm going to do is I'm going to graph the first equation in blue. So I'm starting off at that y-intercept of negative 3. And then I'm going to apply my slope of 2, so go up 2 and right 1. And then we're going to have a line that's going to go directly through those points. So that is the solutions, those are the solutions of the first equation in our system. Here is the next function that's part of our system. We're going to go to positive 4. And then our slope is negative 1/3, so I'm going to go down 1 and then right 3. Down 1 and right 3. Now, I really have got enough points there to see that my two lines are going to intersect right there at the point 3, 3. So that is the solution to my system. All right, a solution to a system of equations is essentially solutions that each piece of the system shares, or each point. So we are simply just looking for the point of intersection of the functions in the system. Now, we've got a couple different methods we could use for solving. We had the one we just did, which was graphing. But then we also have substitution and elimination. Now, graphing is very easy for us. All we're doing is we are typically going to graph on a coordinate plane over here, but also, most of the time we're going to use technology. So it's not one we're going to focus on too much. Primarily, we are going to take a look at substitution and elimination. Specifically today, we're going to look at substitution. So let's talk about the types of solutions. So in our example above, when we are dealing with linear systems, we've got a couple of different options here. In these coordinate planes, we could have, just like our last situation, one point that they share. That means one solution. If the two lines are directly on top of each other, that means they're going to have infinitely many solutions, because every point on the line, which continues in both directions, is going to be shared. And then we are therefore also going to have a situation like this, where our two lines never intersect and therefore no solution. So these should be things we are pretty comfortable with. Again, we have done this before. We are going to apply the same thinking to nonlinear systems. So a couple examples of that is we have linear systems and a linear-quadratic system. So that means we have a quadratic function and a linear function together. As you can see in this example, we have two solutions. We could have something like this with one shared solution. So basically that's what we're looking for. Again, we technically could also have no shared solutions. We have quadratic systems. We have linear circle systems. And then we could also have quadratic circle, which has a lot of different solutions. All right, there's lots of different options we could have here. We are primarily going to take a look at these first three. All right, so let's dive right in. Our first example is y equals x minus 4 and x squared plus y squared equals 16. So this is an example of a linear circle system, because this is a line and this is the equation of a circle. Just to kind of refresh quickly on the equation of a circle, values that are being added or subtracted directly to x and y tell us where the center of our circle is going to be. Since nothing is being added to x and y, that means our center is going to be the origin, or 0, 0. And this is going to be our radius squared, so that means the radius of the circle is 4. Now, we are not going to do the graphing. Instead, we are going to do substitution here. So what I'm going to do is I'm going to take what I know one of my variables is equal to and substitute into my other equation. So the top equation already has my y value isolated. So what that means is I can substitute one equation into the other. And now let's see what happens when I do that. I still have x squared in front, but then my y value is going to become x minus 4 for my top equation, which is still being squared is equal to 16. If you think about what we have here, we have an equation that only has one variable now. It only has x values, and that tells us that we are able to solve for x. So if I go ahead and simplify this out, I have two binomials of x minus 4, which I then can FOIL. So we have first, outer, inner, last, and now I'm going to simplify again. So I'm running out of room a little bit here. But we've got 2x squared minus 8x plus 16 is equal to 16. And we can see we have a quadratic. So to solve the quadratic, because I'm looking for my solutions, I am going to move everything to one side. And we get 2x squared minus 8x is equal to 0. And that's a quadratic I'm going to solve. Now I'm going to move up to the top over here. And we're going to solve this quadratic. Now, because I have two different types of x's, I have an x squared and an x to the first power, I cannot use inverses. I can factor or use quadratic formula. If we divide by a GCF first, that should make our job a little bit easier. And now I can factor. So many of us might look at this and at first find this factoring a little bit more challenging, but essentially all I'm doing is looking for what multiplies into x squared and negative 4x, and that's just x. So if I divide this by x, I get x. And if I divide this by x, I get negative 4 is equal to 0. And now set each one of my factors equal to 0 and solve. I end up with x equals 0 and x equals 4. Now, if we think back to what we were doing above here, we are looking for points of intersection. If they're intersecting at a point, then that means there is an x value and a y value. So if I have the x values, all I need to do is take these and plug them into one of my original equations to find the corresponding y value. Now, it doesn't matter what equation we use, but because that top equation is easier, that's the one I am going to stick with. So first I'm going to plug in 0. I get y equals negative 4, so that means 0, negative 4 is going to be a solution. And then I'm going to plug in 4 for my x value, and I get y equals 0. That tells me 4, 0 is my solution. So these are the 2 points that our system has as solutions. And I can double check by using technology to help graph, but I would find that this is in fact where our 2 equations that make up the system do intersect. All right, so that is how substitution is going to work. We are going to get one equation, have an isolated variable, and then substitute it into the next equation. And then we are going to solve. All right, and that solving process, typically, because our unit is quadratics, is going to involve some type of quadratic solving. And then once we get our x values, we'll have to plug back in to get our y. All right, so that's our first example. Here is our second. So this one's a little bit different. I've got y equals x squared minus 2x plus 1, and then y plus x equals 3 as our system. What I'm going to do is I'm going to move my x value over in my bottom equation. So I have a variable isolated, and now I can take this and I can substitute it into the other equation. So I'll have negative x plus 3 is equal to x squared minus 2x plus 1. And now let's get everything on the same side. I'll get 0 equals x squared minus a 1x minus 2, which I can then go ahead and solve. Now, typically when we're solving these systems, we're going to have nice solutions. Now, that's not always going to be the case, but what that tells me is I should always try to factor. So if I'm going to factor this, both of my binomials are going to start off with x and x, and now I need two numbers that multiply to negative 2 but add to negative 1. That is going to be a negative 2 and a positive 1. Those are my two factors. Set each one equal to 0, and I am going to solve. So I've got my x values. All I need to do is plug back into one of my equations to get the x. So I'm going to use this bottom equation once again. Now, I don't typically want to use the equation that I manipulated because in case I made a mistake, if I plug back in, my solutions will also be incorrect. So I'm going to use the original one, y plus 1x value equals 3. That tells me that y equals 1, and my point of intersection is 2, 1. That is one solution to this system. Then we'll have y plus a negative 1 equals 3. That means y equals 4, and we have negative 1, 4 as a solution to our system. All right, this is another linear quadratic solution because this system has a linear function on the bottom and a quadratic on top, while this one was a linear circle system. All right, and we do have one more solution here, one more problem, excuse me. And we have a quadratic-quadratic, so we have negative 2x squared plus 4x plus 2 is equal to y, x squared minus 2x plus 5 is equal to y. So since both of these are equal to y, one of the variables is already isolated, and I can substitute one equation into the other. So we have negative 2x squared plus 4x plus 2 is equal to x squared minus 2x plus 5. So what I'm going to do is I'm going to move everything to one side. So I'll add 2x squared. I'm going to subtract 4x. And then I'm going to subtract 2. So I get 0 equals 3x squared minus 6x plus 3. I can divide out a GCF of 3 from both sides to get x to the third minus 2x plus 1. Sorry, this should be x to the second. I'm not sure where that came from. And is this the same? No, it's close though. And now we can go ahead and solve this quadratic. Again, we can factor, use quadratic formula. They're not always going to be factorable, but for the most part they will be. So I'm going to find two numbers that are going to multiply to 1 and add to negative 2. That's going to be negative 1 and negative 1. So that means I set each one of these equal to 0, and I get x equals 1 and x equals 1. That means there's only one solution here. So I can take that x value and I can plug back in, which I'm going to do to my bottom equation right there. So I'll have x squared minus 2 times x plus 5 equals y. 1 minus 2 plus 5 equals y. 1 minus 2 is negative 1 plus 5 is negative 4. So 1, 4, positive 4, is our solution. So all that means is this system only intersects once, and essentially what it's going to look like is this. All right, so this is our first day of solving nonlinear systems using substitution. All we are trying to do in each of these situations is isolate a variable, so get either our x or our y by itself, substitute into our other equation, and then solve for our values. Typically what ends up happening is we end up solving for our x values, and then we need to plug back in to find the corresponding y, because the solutions to a system are the points of intersection, which means x values and y values. All right, if we want to quickly check our work, we can plug into some technology and take a look at the graph. As always, thank you for listening. If you have any questions or concerns, please feel free to reach out.